Hello and welcome to TidyX episode 108, TidyX's screencast where we go through and explain how our code works. And this week we're going to be continuing what we started last week. So last week we did an episode on lists. So lists are an awesome object in R. They have a lot of flexibility. We discussed that a lot last week. We're not going to be rehashing that. But this week we're going to be really going into how can you use lists? What are the situations where lists are really valuable? Pro tip, there's a lot of them. And then we're going to go in and explain and just give a variety of examples of ways that we've used lists in our lives as data scientists.
Cool. All right. Well, while Ellis is opening up the script for today, just to remind everyone, if you have questions or feedback, you can hit us up at tidy_explained on Twitter, or you can go to the YouTube channel, like and subscribe, and drop a comment down below and let us know what you think or if there's anything you'd like to see in upcoming episodes. But here we are today, lists part 2, and we're going to be applying some statistical functions to lists to show how you can use them.
Yeah, exactly. So we're going to start off. So we're not going to go through in our markdown this time. This time we're going to be using an R script so that it's all functional for us. We have less comments here and more just pure showing you how things get done. So we're loading tidyverse and Palmer Penguins. Palmer Penguins, just so you have a good data set to work with. We're going to take penguins and immediately assign it to dat because we like using dat. It's a lot easier to type. So one of the things we wanted to show is how do you take your data set that you already have and split it and turn it into a list. So because we didn't really discuss that before, we showed you like how you create a list using the list function. And so there's a function in base R called split. And what split takes is a bunch of indices where you tell it, here are the unique values that I want you to split on. So clump all these unique values together, and based on this index and the data set that I feed it, and turn that into its own list. And so we can take that, feed it into split, and we're going to take from the data set species and say, this is the vector that I want you to be splitting on. And it'll return us a vector of the 3 different species that exist in our penguins data set. Adelie, and so now we have all the Adelie penguins here. We have the chinstrap, and then the gentoo. Split out right there immediately like that. To show you that it works for all different types, or a bunch of different types, we can also split this on island too, and this will be split on the unique islands that exist. And so this will be feeding a vector of islands that exist. So I think it's Dream, Torgerson, and Bisco, which is almost species, but not quite, and split those as well. And this time it's split on the islands. So that is a quick way to do things. You can pass multiple vectors. It doesn't have to just be one, I believe, to split, or multiple indices. So you could like paste together species and island to get a unique combination. But of course, tidyverse thought of this and provided a nice way for us to do the same sort of splitting using their own semantics. So we don't have to do this $sign. You can just pass in the function, use the function group split, or you could previously group by with island and then call group split, and it will split it by island. And naturally, if you have multiple group bys, it'll split it by all of those as well. The same syntax passes on with group split as well. So here we can split by island and species. The downside here is that it doesn't name the list, but you shouldn't be relying on named information like that probably anyway when you're splitting your data set. So that's a quick, dirty way to show you how you can do some splitting. Patrick, do you want to take us and show us how we can calculate some summary stats?
Yeah, let's jump into summary stats. One of the first things that you might do is ask yourself, what are the quantiles of something like bill length across each different species? So here we'll take our DAT, our Palmer Penguins data frame. We're going to pipe it into a group by species because that's the grouping that we're interested in. And we're going to use this group map function from the tidyverse suite of packages. And group map is going to allow us to apply a function to the specific, oh, there it is, to the specific groups. Just saw the help menu there. So here, in order to get this to work, we have to apply the little tilde in front of the function of interest. So here we're going to say we're going to run a quantile function. And .x within this is referring to the data frame that we're looking at. We're pointing at that DAT data frame. We're going to do $x $bill length. And the NARM is there because there are some NAs within this data set. So we just get back returned NAs if we were to leave that out. And then the last thing that we do here is we pipe in just a little set name. So remember, if we were to run this without the set names, we're just going to get back our list, and it's going to be numerically ordered 1, 2, and 3. But maybe we want to retain a little bit of context to this. So we're going to set the names to be the unique dat species. And the reason for the sort is because that list is deposited in alphabetical order by species. So I just make sure that we sort those within the actual unique function right there. So if we run all this, we get a nice list with our cool quantiles that are split out by different species. And there's a number of ways, like most things in R, there's a number of different ways you can do this. So another way you could do this here, the second kind of approach that we take is that we take our DAT, we group by species, we use the group map. So that's all the same. Everything is actually the same for this one. This is in the second approach. This is how to take that list and then just corral it into a data frame. So if you run this, it's everything the same with the addition of data frame. And now you get this nice, cool data frame with, you can see the row numbers are actually replaced with the quantile values. So this would be something that then you could throw into like a GT table or a DT table if you were trying to do a report. Okay, another way that we can knock out this quantile is to make a list call. And this is something that's a little bit unique. It's a little bit different than what we've talked about. But if you go back to our tidy models episode, you'll see a ton of list calls, because most of what gets returned back from tidy models, especially when you're doing model validation, is you're going to get that stuff wrapped into lists within the broader data frame. And this is a way that you can contain lots of information while still retaining the data set or the original data set. So here, the way that this works is we're going to take our DAT data frame, and we're going to select the 2 columns of interest, and we're going to group by species. And now we're going to summarize, and we want to do a quantile. So we're going to summarize, and we're going to create this new quantiles value, but we're going to do it as a list within that summarize. So normally if we were to do summarize, it would just give us a column for the species. Here, it's going to give us a list for the species. And the other thing that we do is we want to retain the data. So we're going to actually wrap the actual bill lengths into its own list. So what's going to get returned here is something that looks like a square data frame, but you could see that it's basically a data frame with lists contained inside of it. And so now, just like we did with the tidy models in the tidy model segment, if we want to grab one of those, we could do something like, hey, let's grab the quantiles for Adele. And so by using the pull function, we're just going to pull out the information there, and there you can see those quantiles. And then if we were like, you know what, that's kind of cool, but I might want to do something with the actual bill length data, like maybe plot a histogram or something like that. Why don't I go ahead and grab that? And that's all of the Adele data. And you can see that we just contained a whole bunch of information, summary stats, the full data, all within that little 3x3 data frame, just by doing this cool list call.
Mm-hmm. List calls are awesome. I use them all the time to help organize my thoughts and put things together when I'm dealing with weird objects. Automatically just throw them into a list. That way I don't have to worry about, is it square? Is it going to fit nicely within my tibble? It just organizes this way. One quick thing to note, though, is list calls really only exist inside of tibbles. They don't exist inside your basic data frame objects. And so
they're native to tidyverse.
Yeah, so you will be needing the Tibble library to be doing this sort of thing. But if you're working in Tidyverse, you already have that loaded into your namespace anyway. So it's not like it's a big lift or a big change. It's just a thing to note. If you're trying to call as.dataframe on this, you're going to have a bad time. Yeah. It's just not made to store like that. All right, the next thing we got is, okay, now that we've got our data set, how do we do regressions with this? And so as you can see, the very beginning of this isn't too different. We have two different approaches that we're going to talk about here. So the first part is we're going to take that. We're going to pipe it to a select and subset to keep species, build length mm, and build depth mm. And then we're going to group by species again, because we want to do our regressions by species. And then we're going to throw it into a group map like we did before. The unique thing here is we're going to have two functions kind of nested around each other. So we're going to do our tilde, going to use the broom package to help tidy up and clean up the results of our regression model. And then we're going to use the lm function here to generate a linear model on bill depth based on bill length. And we're going to pass the data, and it's going to be based on the .x data set, which is the subset group for each set there. And so we can run that, and it'll return group map will by default return a list because it's a mapping function. And so here you can see that we've got a list, and this is the Adeli, that's the Gen 2. What's the chin strap? Adeli chin strap. Yeah, but you can see it's not named. It's not super easy to like remember off the top of your head. One thing to also note is when you're doing like a group by and then performing some action on it afterwards, like mapping, it's probably going to be ordered alphabetically, or if it's a factor, by the factor levels or something like that. So that's always a thing to kind of keep in the back of your mind when you're doing these maps, is it tends to alphabetize them. Mm-hmm. So if you don't want that to happen, you need to kind of keep that in mind. So that's one way that you could run, and as you can see, we can see the three different regressions and the intercept and bill length, mm, and the estimates there. So that's cool. But what if we want to actually show everything together nicely in a nice data frame? Another approach we can take is we can take dat. Once again, we select the columns that we care about. We once again do a group by, but this time we're going to do group split. And I mean, technically we could have put this group split instead of the group by, but what this is doing is now going to split this data set into the Gen 2, or the Gen 2, the chin strap, and the Delhi penguins there. We're going to throw that. So now we've got a list. And so now we can use it like we normally do with other per functions, but I immediately want to turn it back into a data frame because I want to be working with data frames. So what I can do is I can do map DFR. So map DFR says map across the list that I feed into it and return me data frames, or expect data frames to come back and bind them together by row. So we're going to write an anonymous function. The only input is X, which is the data set that is for each list element here. What we're going to do is we're going to turn a data frame where the first argument, or the first column, is going to be species, and we're going to take the unique X species. So this is going to give us the unique species that data set has. And then the second piece is more or less the same code that we ran up here. Instead of it being .x, we're passing x because that's what we're passing here, and that's going to return a data frame. And a data frame containing a data frame, it just concatenates them nicely together. So we can run that. And so now we get, in addition, now it's a data frame as opposed to a list. And we get the nice added benefit of having which species this intercept and build length comes from. There you go. So now it's a lot easier to remember. You don't have to remember off the top of your head what is the order in which these guys were evaluated in. Patrick, you want to take us through this one?
Yeah. So last week we went over a few base R list functions like lapply and supply, or sapply. And those allowed us to pass functions to specific vectors of data and get back some sort of summary stat. So one that I use all the time, though, is this by function. And so the way that it works is you pass it the vector of data that you're interested in this case, bill length, and then an indices. So in this case, we want to look at bill length by island, and we want to get the quantiles returned. And again, we'll pass NARM equals true because we want to remove any NA values. And when we run this is a handy way of getting returned a quick little list. And obviously we can call elements from that list. If we wanted to get out, say, one of the islands versus another, we could just yeah, there you go.
I was like, what do I name this? I don't
Yeah.
want to give it dat
Yeah, right.
because we already have dat. And then we'd have to go up.
So you could call exactly one of the any one of those island types. So super handy. It'll take any of those functions like quantile, mean, standard deviation, median. Here we do the same thing, just calling this time by actual list notation. So we're piping in that we want the first element within that list. Here's another way to do the same thing. Instead of, if you don't want to do the dot brackets, you can use the tidy function pluck and pass it the number of the element that you want. In this case, it'll be the third element. And then if we scroll down a little more, we get into how we kind of split this data, different ways of splitting this data out. And we're going to run some correlation coefficient here. So Ellis, you want to go through this part?
Sure thing. So we take, once again, we start off with the penguins data set. We're going to subset to keep the species, build length and build depth data sets, and we're going to call group split on species. Stuff that we've now done a couple times here, but of course we wanted to start each chunk off with a clean data set here. So we wanted to show a couple different ways that you can pull data out. So of course there is the pluck function there. So you can do species split, pipe, pluck, and then the index that you want to be pulling from. You can also pipe and dot. So in piping, dot represents the data that you're passing to it. And then here we're saying, okay, we want the first entry from the prior thing that got passed to it. And so that's why this thing works. But under the hood, under R, square brace is actually the function that we're calling. So if you actually type into your console just square brace, surprise, this is actually a primitive function that exists at like low level R. The R interpreter knows how to handle this. And so I am a garbage person, and this is how I tend to write my pipes, because in my brain this is a lot clearer to me than this dot square brace one. What I'm saying, because of the way pipes work, because pipes expect functions in the next set here, I'm saying species split pipes into the function square brace, and I want the first entry there. And so that is just how my brain works when I'm writing pipes. This, I think, is probably a little bit more clear to the general person, but for some reason I can never remember this. And so we just kind of wanted to show you the three different ways that you might see somebody selecting an element out of a list in a pipe, just so you're aware of what they look like. Same idea actually works with the double braces too, is that this, here, I will put this actually below. This is the same function, or results in the same evaluation as this, because we are saying the exact same thing. Take species split and get the first element out of it. Mm-hmm. But the difference is this is the single brace, so this is still a list when you pull it out. But this time we have now pulled out the actual data frame. And so I think pluck is more similar, is more like this one. Sorry. Mm-hmm. Sorry, that was just a bit of setup and information too. So you can actually look at some more complicated ways that you can apply things. So this was actually something that when Patrick and I were thinking and talking about lists, Patrick thought about this example and was like, this is a weird thing that let's talk about this so we can explain how this works to people. So we have our species split data set here. Right, so that's a list of the different the data set split into the different species, and we're throwing it into a lapply. So what we know with a lapply is it will apply whatever function we want to each individual element. So we don't have to go in and say, I want to apply it to element 1, 2, and 3. Lapply will apply whatever function that we want to that. The second argument is a function. And so even though it's quoted, what we're saying is we want to apply the single square brace function to each element of a species split. After that, Lapply technically has triple dot notation. But what that means is now you can pass whatever arguments that would go into this function here. And so what this is saying is by using just true, that is going to go into the first argument of the square brace. And the square brace, if the first argument is just set to true, that's going to select all the rows. And then the second argument here is saying that I want to remove the first column, because if you pass into a square brace, you're probably more familiar with seeing something like this. This means remove the first column, right? Because this is a negative index, which is saying remove, or out of my data set. Mm-hmm. So this is saying loop across every species split, and for each entry, keep all the rows but remove the first column. And there you go. As you can see, the species column was now removed from all our data sets. Now, if you wanted to be a little bit more verbose in your code, you could definitely do that as well. You could write it like this, where you initialize species split 3 as a list. Now, for every index along species split, so this is just going to return an index 1, 2, 3, a species split, we're going to go into each element. So we're going to use the double square brace to get into the specific element of species split. And then we're going to remove the first column. And then we're going to assign it into species split. So now we've run that. And as we can see, these two are the same results. Boom. So that's the same way to write the same exact information, but as you can see, this is a lot more terse. So whatever floats your boat. All right, so Patrick, do you want to take us through this? I think this is the same sort of idea here, where
we just take the split out data now and we put it in this Lapply function, and we're going to use again an anonymous function. And for that anonymous function, we're going to take a value x, which is going to be each of the data within each of the lists, which remember is 2 numeric columns now. And because the columns are numeric, we're going to dump those into this correlation function. And the pairwise.complete OBS is just saying if there's NAs, do pairwise deletion, so remove the full rows. And I'm going to round by 2 so that we don't get crazy significant digits. And if we run that, we get a correlation matrix for each of our, for the bill length and the bill depth for each of our different species, which we split out. So that's kind of cool.
Yeah.
And then the final thing we can do here is, well, let's make a report. And lists can be really handy if you want to build a multi-page report. So we're going to take our penguins data.
Yeah,
First thing we
good.
Oh,
Is that all good?
No. We'll keep penguins because we're going to, instead of using dat, we're actually just going to get rid of the NAs. So NA omit is just going to get rid of all the NAs that were in that penguins data frame. And so now we have our penguins data frame, and we're just going to set the theme to classic. And we're going to create a plot. So the first plot that I want to create is what we're going to then build into a multi-page report. If we run this, it's going to take that penguins data and return a GG plot where it's gender, sex, male or female on the x-axis, and then the flipper length on the y-axis. We're going to get a violin plot, which is basically like a mirror image density plot, you'll see. And we're going to actually take the points and we're going to jitter them on top of that plot. And we're going to facet wrap this by species. So basically, we want to have a different facet per species. And so if we run this, we get a nice looking...
Scales free x means that the x-axis may not be the same.
I don't know why I said that. Yeah, you could delete it. I think I originally said that when I left the NAs in there.
Yeah.
But now it's good. Okay, so cool. So now we have our our nice little plot here. But what if we wanted each one of those species to be its own page in a plot? So we wanted to print this out as a PDF. So the first thing I'm going to do is I'm going to say, well, we need to create a function that creates the plot for us. So the plot function that we're going to create here takes the penguin, so the type of penguin that we want, Adelie, Gentoo, or Chinstrap. And within this function, it says, hey, go to the penguins data set. And from the species column, select the penguin that has just been passed into this function called plotfunc and create this same violin plot. And then the only thing that's different here is at the bottom, I gave it a GG title and I actually pass it the penguin species that we put into the function. So I want that to be at the title of the plot. So if we run this, we get a plotting function that we can then check out and see if it works here. If we say, hey, let's make a plot for Gentoo. And there's the Gentoo plot. And so now we want to use this function and create a page per species. So we're going to first use this PDF function, which is basically saying, hey, we're going to go ahead and we're going to store a PDF. It's going to be width 12, height 8, and we're going to call it penguin.pdf. It's going to be in that folder right there, the working directory that it's pointing at. And we're going to use lapply. So this has been a super handy function for us today. We're going to use lapply, and we're going to say within lapply, get the unique penguin species. So it's going to be Adelie, Chinstrap, and Gentoo. And for each one of those, pass them into this plot func. And then when you're done running, just dev off. So turn it off. So if we run those 3 lines of code, R is just going to reproduce this boop, boop, boop. It gives us the 3 little lists that we see right there. Now we'll just take a look at this report. If we do file show and we call it from our working directory, we get our PDF. And now every single species has its own page. And so this is a way that you can build multi-page reports at work or something like that, just using lists.
Just at the click of a button. Super quick. Of a button. Mm-hmm. There you go. Send this off to your boss. Hey, you go.
Have fun.
All the penguins that you could possibly care about are right here, and you can look at the different plots. Be sure to take into account that these plots are specific to each one. So
yep,
you can't exactly compare these two 1-to-1 exactly. But
that's right. That's right. That's right. You could if we set the X limits or the Y limits, sorry, but maybe that's for a different episode.
Yeah, exactly. But yeah, so that is a quick look in the ways that you could actually use lists, that they are functional for everyday use in your life as a data scientist, and the way that you can apply it and kind of work with it. You'll find as you become more comfortable with lists that they kind of just start to become your default. I don't know how I want to store this data, or I don't know what the data this will take, or the shape this will take. I'm going to just throw it into a list because the list can hold it for me, and that's a problem for future me. Right now, me is not going to worry about it.
Yeah.
So yeah, with that, I guess we're going to call it. Thank you all for joining us for episode 108. As always, my name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick, and at Tidy_explained is the home of the screencast on Twitter. Tidy.explained@gmail.com is where you can hit us up with an email. Most common way to get in touch with us, though, is to go to YouTube, like and subscribe, and drop the comment down below there. And we do have a Patreon page if you feel like supporting our work and you feel like this screencast has been helpful to you in your everyday work. We are appreciative of any contributions.
Yes. Thank you all so much, and keep on exploring your world.